Problem 10.3. Calculate the following limits. Okay, so in this case, it's just an application of that the Riemann sums thing. Okay, so remember that this is what we have to write. This is the sum of the value of a function f at some point c, and then times xi minus xi minus 1, right? From I equals 1 to n. Okay, so the first one, we have the limit when n goes to infinity of the sum from k equals 1 to infinity, sorry, well, to infinity, that's the limit, to n of this n over n squared plus k squared. Well, if we divide everything by n squared, right, we have 1 over n times 1, and then we have this is 1 plus k over n squared, right? So now this is the value of the function at kn. This is the difference between the intervals, right? This is a regular partition. So this limit is going to be the integral between 0 and 1 of this function. So this is 1 over 1 plus x squared dx. And this is the arctangent of x between 1 and 0. And this is pi half, so pi over 4 minus 0, so pi over 4. Okay. Now for the second one, we have the limit when n goes to infinity of 1 over n, okay, times the sum from k equals 1 to n of the nth root of e to the k to k. We can rewrite this as like this, e to the 2k over n. Okay, so this is f to the k over n, where f is e to the 2x, right? So this is the integral between 0 and 1 of e to the 2x dx, and this is 1/2 of e to the 2x between 1 and 0, so 1/2 of e squared minus 1. Okay, and then finally we have the limit when n goes to infinity of the sum from k equals 0 to n minus 1, okay, of 1 over n squared minus k squared. So if we take a common factor here, right, we have n squared minus k squared equals n squared 1 minus k over n squared, and then we take, this is the square root of that, so we take the n squared out, so this is 1 over n times the square root of 1 minus k over n squared. And now again, this is the value of the function f at k over n. This is the width of the intervals. This is the integral between 0 and 1 of f, which is 1 over the square root of 1 minus x squared. And this, if you don't remember, is the arcsine of x between 1 and 0. Now what's the arcsine of 1 is pi over 2, right? The arcsine of 0 is 0, so this is pi over 2.